Good day, everybody. How are you all doing? Today, we are going to talk about a problem in Poisson distribution. So, without further ado, I will share my screen with you. Says the switchboard at an office gets an average of 5.5 calls per hour. The staff can handle up to 6 calls in an hour. Let X be the number of calls received at noon. Find the mean and standard deviation of X. Part A. Part B, find probability of X less equal to 6. Part C, find probability of X equal to 6. What does it mean to the staff who can, on the average, receive 5.5 calls at noon? And then the last part D is find probability of X greater than 8. So I'll start with the equation for the Poisson distribution, which is But before I get started, let me create some space for myself. Okay. Okay. Or maybe I'll change the color. How about that? And, so the equation for Poisson distribution, uh, the probability of X occurrence in an interval of, say, time here an hour for a variable here phone calls, where mu, Greek letter mu, is the mean number of occurrences per time, per unit time, or in this case per unit hour, is given as, so I'll write the equation for Poisson distribution is probability of X comma mu is equal to e to the power of minus mu, then mu to the power of x. So this is multiplied by mu to the power of x divided by x factorial divided by x factorial. So in this case, mu is the mean number of phone calls received per hour, and E is equal to 2.7183. So the first one asks is find the mean and standard deviation of x. So the mean of, so part A, mean of x is equal to mu, okay, is equal to, as given in the problem, is 5.5, okay. And standard deviation of x, standard deviation, sorry, deviation of x equal to square root of mu is equal to square root of 5.5, and that is equal to, use a calculator to get the square root of 5.5. So second button, this is with TI-84 calculator, second and x square, which is the key in the middle of the first column of keys in the left. Second x square gives you the square root. Inside the square root, type in 5.5, and the answer is 2.345. Okay, so that's the standard deviation of x. Part B, probability of at most 6 calls, at most 6 calls, which is equal to probability of x less equal to 6. And I will use my TI-84. So what will I do? X less equal to 6 means P of 0 plus P of 1 plus dash 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 up to P of 6. So we will use the TI-84. So first we will press the second key. Then we will press the verse key. And then we will scroll down to second verse, scroll down to Poisson CDF, because it's adding from 0 to 6, we use the CDF, cumulative distribution. So we'll scroll down to Poisson CDF, okay, and hit enter. Hit enter. After we go down to Poisson CDF, enter. Then they ask for lambda value. Lambda is same as, sorry, let me write it clearly. This is lambda they ask. Same as mu in our case, which is the mean number of calls per hour, 5.5. Then they ask for a x value. We want to add from 0 to 6, so the last number is 6. So x value is 6, and then we go down to paste. So let me move up a bit again. And then we go down to paste and hit enter. Enter twice. Whenever you are on paste, you have to hit enter twice. Okay, and the answer is answer for Px less equal to 6 is equal to 0.686. Okay, so that's part B. Part C, Px equal to 6. Here again we go through second verse, then verse. We press the second key, then the verse key. This time we scroll down to Poisson PDF, because we will find the value of probability of x only equal to c. So instead of using the CDF function, we will use the PDF function and then enter. Okay. So second verse, scroll down to Poisson PDF and hit enter. Lambda again is mu basically. So lambda is equal to the mean number of calls per hour is 5. Oops, sorry about that. Let me take care of that. Lambda is 5.5. Okay, so we type in 5.5. And then it asks for an x value. The next line is an x value. So x value is, we want to find the probability at x equal to 6. So x value is 6. And then we go to paste. The next line is paste. And again, we bring the cursor on paste and hit enter and enter. And P probability of x equal to 6 is equal to, so paste enter and enter is 0.157. Now the question has been asked, what does it mean for the staff who can on the average receive 5.5 calls at noon? So we create some more space. Okay, back to this. It means that there is 15.7% chance that of receiving 6 calls at noon. So the staff needs to be prepared to handle 6 calls if necessary. 6 calls if necessary. Okay, only 15.7% chance. The last part is what is the probability for x greater than 8? Now we will do it using the complement rule. Complement rule states that the probability of an event is 1 minus probability of complement. Now complement of x, that means opposite of the complement of x greater than 8 is x less equal to 8. So by using the complement rule, probability of x greater than 8 is 1 minus probability of the complement event, which is x less equal to 8. So which is, because it's less equal to 8, we are adding from 0 to 8. So let me write that out. 1 minus in parenthesis P0 plus P1 plus dash 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 up to P8. So we can do that easily in our TI-84 calculator. What we will do is we will type in our calculator 1 minus, then second verse. Let me take care of that. Second. There is 1 minus second verse and scroll down to Poisson's CDF, and then enter. Your lambda, remember, is the average number of calls per hour, 5.5. Your x value is 8 because we want to add from 0 to 8. Enter. Sorry, this is pest. So let's go to pest, not enter. So this is your x value. X value is 8. And then we go to pest. And remember, whenever we are on pest, the cursor we have to enter and enter, or enter twice. And so this becomes equal to then Px greater than 8 is equal to 1. So 1 minus second verse, scroll down to binom CDF because the complement is 0 to 8 and you're going to take it out from 1. So lambda is 5.5, is same as the mu in our textbook. Mu is the mean number of calls per hour. X value you want to add from 0 to 8. X value is the last value, is 8. And we paste, enter, and enter. And the answer is 0 0.1056. Okay, so probability of x greater than 8, we use the complement rule, which is 1 minus probability of x less equal to 8. And then we use the uh, Poisson CDF function because we want to add from 0 to 8. So 1 minus second verse Poisson CDF, lambda is 5.5, x value is 8, paste, enter and enter. And so we get probability of x greater than 8 as 0.1056. I'll stop here today. If you have any question, comment, please write me a note. I'll get back to you as soon as possible. And if you like this video, please give me a thumbs up. I really appreciate it. And if you have liked also, please let your friends know about this video so that you and themselves, you all can subscribe to my channel by hitting the red subscribe button at the bottom right corner. Thanks for watching. Have a nice day. I'll see you next time when I come back with another problem and a solution. Take care. See you. Bye.